I need an answer to this Pythagorean with math. Let me say it all at the same time. The sooner I get the answer to this Pythagorean with math, we can go on to what is my favorite day of math class. Because chapter 8 is my favorite chapter. I wait all year to do chapter 8. If I could just do chapter 8 over and over and over again, I probably would. You're about to find out because it is the best. No more proportions. No more quadrilaterals. And what's the difference between a rectangle and a square? No. Today is the day. But to get to that, I've got to surpass the bell ringer. I need an answer to the bell ringer. Ayana hasn't finished coloring my data thing. I should show it to you, though. She's going to finish coloring for me. And the reason I have to show it to you is, like I told you out loud the other day, second period. It's hard to see. Come on, please. Okay. Second period is the period with the highest percentages, which means you're the best at this kind of question. So how would the second period not have the answer to bell ringer? Someone tell me the answer to bell ringer. Oh my goodness, let's add all the whats. I don't mind working it. Okay, if you added all the one-story homes, what was the total number of one-story homes? 222? Okay. So back to, Katie had an idea because it said specifically of those who live in a one-story home. So she added up all the one-story homes. Well, actually, Danny did that part. She got 222. Do we divide it by 6? You did 222 divided by 6 and got 37? Is that what you're supposed to do? Okay, so this is math you told me. What are you ignoring in the directions? What's the end of the sentence say? Okay, 29.1 to 35. What number do I need to put in my numerator then? Yes, because 29.1 to 35 is this column. I mean this row. So where they overlap is the 47. So I need to know 47 divided by 222. .21, which would be 21%. Perfect. The answer is B. Katie, back at it. Why did you pick B over any of the other answer choices?
To be honest, I just circled it.
But why? There's a reason why you did. Why?
Because it wasn't like...
If I had guessed, I would have guessed B. Why would I have guessed B?
I don't know, I just picked it.
Why would I have guessed B? If I was guessing.
21 can be split.
Oh, 12 is 21 in reverse. Exactly. So I felt like they were pointing to B with answer choice A. Perfect. Yes, agreed. They're forwards and backwards. 21, 12, 12, 21. I got it. I noticed a number pattern. That's why I picked B. Okay, get out your notes for today. Okay. Oh. Yes, ma'am. No, ma'am. Today is my favorite day of math class. It is the most important day in my mind so far, that is for sure. There's so much in the next two sections, 8.2 and 8.3, that we're actually going to test after only 2 sections. That's how much stuff is in the next 2 sections. We're going to be on 8.2 today and tomorrow for sure. Possibly today, tomorrow, and the next day. Just depends on how life goes. That's how important 8.2 specifically is. We're going to be stuck on it for a while. We've got to get it all. We're not even going to talk about that second learning target today. That's tomorrow's problem. Today's only problem is I can use the Pythagorean theorem. We've got to be able to use the theorem a squared plus b squared equals c squared. If you did not know the Pythagorean theorem, then you need to memorize that bad boy as soon as possible. It's the alphabet. Surely you can handle A, B, and C. The most important part of this theorem is the part that they wrote in parentheses. It only can be used on right triangles. So if Brandon tries this on any willy-nilly triangle, he's going to get points counted off. It only works on right triangles. Okay, remind me, what is the side across from the right angle? What's the name of that? Okay, I knew y'all would recall that. Okay, so the hypotenuse is the side always across from the right angle. In fact, I'm going to go ahead and label the hypotenuse in all my examples. So in number 2, it's 12. In number 1 and number 4, it's an x. In number 3, it's a 15. I draw an arrow from my right angle to my hypotenuse to help me know for sure this is the hypotenuse in case I get confused. That's really the only mistake Grant can make, is to not pick the right thing for the hypotenuse. That's why I draw the arrow, so I will never make that mistake. Okay, there's only one rule with the Pythagorean theorem. Does anyone know what that one rule is? What's the one rule? Okay, I'll tell you. The one rule is that the C has to be the hypotenuse. It has to be the hypotenuse. That is the only rule. Otherwise, it doesn't matter. For instance, I'm going to start with number 1. I can put 4 squared plus 7 squared equals x squared. Or I can do 7 squared plus 4 squared equals x squared. It does not matter what Sawyer picks for the A and the B. It only matters that the C is the hypotenuse. He will never mess up as long as the C is the hypotenuse. Well, he will never mess up with the setup. Let's say that. Okay, help me with my math. What is 4 squared? What's 7 squared? Okay, and that equals x squared. What is 16 plus 49? Okay, so 65 equals x squared. How do I get rid of that tiny 2? Okay, so if I take the square root of both sides, I'll get square root of 65 equals x. What times what is 65? It's 5 times something, obviously. 5 times 13?
Yeah.
Okay, 5 and 13 are not perfect squares, so I cannot reduce this radical any further. Oh yeah, we're back to that. We did that from bell ringers for a while, just for this chapter. So that is my final answer. If Sydney puts that and circles it, she's going to get all her points. However, let's say it had a different number. Let's say it said square root of 64 equals x, and she circled that. Would I give her all her points then? No. Why is that? What is the square root of 64? 8. So I would only give her all her points if she had x equals 8. You can see how this could be an issue for her. Or for anyone. Picking on poor Sydney. Okay, since I'm already picking on Sydney. Sydney, how do you want to set up this next one?
8 squared plus x squared equals 12.
Sounds great. Okay, 8 squared is 64. 64. So I have 64 plus x squared equals 144. I subtract 64 from both sides. I get x squared equals something. 80? Thank you, Toby. So I get x equals the square root of 80. Toby circles this answer and he thinks I'm going to be happy, but I am not, because 80 can break down. I need a perfect square that multiplies to give me 80. For instance, I know 10 times 8 is 80, but 10 and 8 are not perfect squares. 40 times 2 is 40, or 2 a perfect square? 2 is a perfect square? We know the square root of 2?
Miss Compton, can you send Skylar Lamore to the attendance window for a minute, please?
Yes, ma'am.
Thanks.
4 times 20 is a good one. However, there is a bigger one. We're wanting the biggest perfect square that goes into 80. And the only reason I know this is because I swear that's what I've been doing for days in Algebra 1. That's what radicals is. I know 16 times 5 is 80. 16 is a better one because it's bigger than 4. She said 4 and 20 is not a bad answer, but there's a better one. It's 16 and 5. Okay, so I've explained this before, but it's been a while, so I'll explain it again. They get a divorce. It's sad, but it happens. I know what the square root of 16 is. That's 4. I don't know the square root of 5. So my final answer is 4 square roots of 5. If Grant leaves his answer at square root of 80, he's missing out on probably about 3 points per problem. There's not that many like this, but so he goes from 100 to a 97 to a 94 to a 91, and the next thing you know, what he thought was going to be an easy A is blown, all because he didn't try to simplify his radical. Okay, let's do Mark. You knew it was going to happen. How do you want me to set up number 3? Thank you, Mark. So I have 81 plus x squared equals, what's 15 squared? 225? I don't know.
Yep.
225. Okay, so I subtract 81 from both sides. I get x squared equals something. 144. Okay, so Mark has worked so hard on this problem. He gets x equals square root of 144, and he circles that answer. Is Mark getting all of the points he can from me? No, why? To what? Because the square root of 144 is 12. So he needs to put x equals 12 in order to get all his points. Okay, Addison, just because you made eye contact. Tell me how to set up number 4. Okay, perfect. So I have 25 plus 64 equals x squared. So I have 89 equals x squared. So I get the square root of 89 to equal x. Man, I sure do wish I knew something that went into 89. I can't come up with anything. Please try to find something. I think it's prime. I can't find anything. So if you find something, let me know. Otherwise, I'm pretty positive that's the final answer. Okay, are there any questions about this? This is dire. So if Sydney messes this up and picks the wrong number, because what's going to happen, because there's at least 2 people that have tuned me out, so they're going to think that x is always the c. That's not the case. Look at number 3, look at number 2. The c is always the hypotenuse. Don't assume x is the c. It's not going to work out for you. Okay, so the good news is that in a few minutes I'm going to give you a puzzle, and you can do most of them just like that, probably even faster once I teach you this next trick. The bad news is that you have a quiz on Pythagorean triples on Friday. Let's talk about what that means and why I need you to know them. Okay, so this chart at the bottom of your paper. You can, if you want to, memorize the whole chart. I have not. I've only memorized the ones in bold. I know 3, 4, 5, 5, 12, 13, 8, 15, 17, and 7, 24, 25. Those are the only 4 that I've memorized. And you would say, but Miss Compton, there's a whole big table. Why did you not memorize the rest of the table? I don't have to. I know my multiplication tables pretty well. I know 5 times 2 is 10, 12 times 2 is 24, 13 times 2 is 26. Oh my goodness, this is just a multiple of that. Same thing with 6, 8, and 10. 3 times 2, 4 times 2, 5 times 2. Everything else in the list, in the chart, is a multiple of those 4. So if Trey learns those 4, and he's pretty good at his multiplication tables, he can figure out the others. So let me show you why they're called a triple. I'm going to show you with 3, 4, and 5. They're called a triple because 3 squared is 9, 4 squared is 16, 5 squared is 25, 9 plus 16 is 25. That's why they're called a triple. It works with 5, 12, 13, 8, 15, 17, 7, 24, 25, and any multiple of those 4. Those are the 4 triples we use the most often. Is there a whole giant list of more you can memorize to amaze me? Of course. So, what happens on Friday is that there are like 8 questions or so, and it'll say, all you have to do is write yes or no. Is 5, 12, 13 a triple? Yes. Is 10, 24, 25 a triple? No. Is 24, 45, 51 a triple? Yes. You just put yes or no. If Sawyer gets stuck, could he always check using the Pythagorean theorem? Yes. That's why Sawyer's only going to have so much time, so he might can check 1 or 2, but he can't check every single problem with the Pythagorean theorem, because otherwise he didn't actually learn his triples. Are there any questions about this? There is a quiz on Friday. So let's flip to the back and see where these triples are useful. Okay, I don't care if for now you cheat at the front. You can flip back to the table on the front if you want to. What should x equals without me actually using the Pythagorean theorem on number 5? 12. She said that so fast. 10? 10. Okay, she looked at her chart. She saw 10, 24, 26. That's very smart. However, you realize Faith is eventually not going to have this chart. So how could Faith have figured this out otherwise? Let's see. What's 24 divided by 2? Okay, and then what's 26 divided by 2? 13. So really, this is a 5, 12, 13, where each side has been multiplied by 2. 12 times 2 is 24. 13 times 2 is 26. 5 times 2 is 10. That's how I knew it was 10. Okay, number 6, let's do something similar. What should x equal? Okay, 13 you said? 15? 15? Say it again. 15. Okay, you can look at your chart and cheat for now. 15, 36, 39. Or, what's 39 divided by 3? 13. What's 36 divided by 3? 12. Again, I have a 5, 12, 13, where all the sides have been multiplied by 3 instead. 12 times 3 was 36. 13 times 3 is 39. 5 times 3 is 15. Sawyer's not having to use Pythagorean theorem at all. He's not having to work out anything. He just knows these. It makes his life so much easier and faster. So when I hand Sawyer 20 problems in just a second, he knows that probably about 10 of them he can use these triples if he's real smart. He does not actually have to work out the Pythagorean theorem on all of them. We're only going to do one more. I saw that look, Trey. I saw it. Okay. We're not going to do number 8, although word problems are why the Pythagorean theorem is the most useful, because it happens actually like for real in real life, where I get a lot of stuff I try to make happen in real life and it really doesn't happen. Okay, so here's my building. It says that there's a 20-foot ladder. There's my ladder. And that is placed against the building to reach some window. Here's my window. 16 feet above the ground. How many feet away from the building is the bottom of the ladder? Okay, it sounded like a weirdo problem, but really, I have a right triangle. Where do I put the 20? On the hypotenuse, which is because that's where the ladder is. Where do I put the 16?
On the side of the window.
The side with the window, not on the ground?
No.
Okay, I put it on the side with the window because I want to know how far away the ground is. Okay, so Alex has 2 options. He can, of course, do x squared plus 16 squared equals 20 squared. I'm going to keep doing that until you tell me my other option. Oh, it's triple. 16 squared, 256, Sabdi. Okay, and then 400 minus 256. So x is the square root of 144. So x equals 12. Yeah. Okay, so I can do all this, which Alex doesn't want to do. Instead, he would much rather figure out a triple. What number goes into 16 and 20?
4.
What's 20 divided by 4?
5.
What's 16 divided by 4?
4.
So which triple is this? A 3, 4, 5, really. And each side was multiplied by how much?
4.
So what should x equal? 4, because 3 times 4 is 12. So I realized 5 times 4 is 20, 4 times 4 is 16, 3 times 4 is 12. I know the bottom is 12. So Alex has options. He can either do all this work, or he can just tell me which number it is because he gets his triples and he knows multiplication pretty well. if Alex wants to do this on the test, if he just wants to write out Pythagorean triple or just put PT so I know that's how he figured it out, that's fine. I'm not going to count off if Alex is just using a Pythagorean triple. Unless, of course, he uses it wrong, in which case that would be a shame. Are there any questions? Okay, so I'm about to hand you a puzzle on one side, and then on the other there's some problems. The puzzle side has a lot of triples. The back side has a lot of triples. Triples are about to be very useful. It spells out something at the bottom. If it doesn't spell out English, you've done it wrong. It is not due tomorrow. I do need you to work on it. And as long as we work hard for the remainder of class time, we do not have to finish it for homework. But trust me, you'll have like 75% done.
Wait, this is due today?
No,
But he says not due tomorrow.
I said it's not due today. We'll probably finish it up tomorrow. You don't have to finish it for homework. As long as you work hard, Katie, you'll finish half of it today and the other half tomorrow. I'm not gonna be sure about that. No, I didn't finish question yet. I don't care, since this is your first time with triples, if you have to use your triples chart to figure some of these out. I swear it would make your life so much easier. And since Alex can use triples on a lot of these, there are quite a few questions that don't require any work at all. For instance, E requires no work.
No, just
You don't have to do all the work if you recognize the triples.